Hey folks, welcome to my first IXL video. I'm going to try to sound a little bit coherent and I'll try to explain anything that I'm doing. Hopefully you can see what I'm up to, and occasionally I'll use a shortcut and try to explain it in a brief statement or something. But if you watch what I'm doing, you may be able to follow along. I will try to explain as I go what's going on. I'm going to be doing comparing and ordering rational numbers. This first one, we want to use an inequality and describe the comparison. And obviously 15 is greater than 1, and we have a common denominator. So we want greater than. In the next one, these are rational numbers again. So that means that they're ratios. A good point is that rational means ratio. Let me see. There we go. Come on. Oh, it's not letting me write on the screen. Oh, now it is. Rational ratio is a rational number. So here's a ratio. This is 0 is always less than a positive. So there you go. Which sign makes the statement true? Now for me, I immediately see 1/2 as 0.5. And I see 2/5 as 0.4. And since 0.4, oops, 0.4 is less than 0.5, we want this one. Okay, now we want to go from greatest to least. Now it just so happens that negative at the end is there correctly. The others, notice, are all multiples of 4. And it looks like we can't really reduce the 15 over 24, but it happens to be 3 over 8. So this is 3/8. And that happens to be 0.375, if that helps. And 33 over 44 can't be reduced. Can't think of any nice way of reducing that, but it's really close to 3/4. So I'm just going to call it 3 over 4 approximately. So it's about 0.75. If any of them are even close, then I'll change it up. The 12 over 32 happens to be exactly, let's see, divide by 4. That's going to be 3 over 8. Wait a minute. 3 over 8. Oh, this is 5 over 8. What a spaz. Okay, so that is 0.625, and this one is 0.375. Jeez, I can't. Bad day. I think I'm going to start this all over again. How embarrassing. Anyway, it looks to me like we've got this guy is going to be our first one since he's the largest. He's pretty close to 0.75. And then it's going to be my 15 over 24 and then my 12 over 32. So let me turn this off for a second. I'm going to put this one first, and then this one next, and that one next. And there it is. Okay, let's see if I can be a little more coherent this time. All right, so first of all, we want greatest to least. So we want our biggest negative last. And it just so happens that negative 12 over 15 is a lot smaller than negative 2 over 20. Lots of ways of thinking about it. One way, I think I'm going to write my units. I'm just going to write some of my values over here. So negative 12 over 15 is negative, see if I can write it correctly this time, divide by 3 and you get negative 4 over 5, which is negative 0.8. We've got a negative 2 over 20, which is the same as negative 1/10, or, negative 0.1. And we've got 3, which is going to be our largest. I've got 9 over 10, which is 0.9. And I've got 21 over 35, which happens to be divided by 7, and you get 3 over 5, which is 0.6. So it looks like, let me turn it off. We've got the 3, which is first. Then we want the next bigger one, which is 9 over 10. Then we want the next bigger one, which is the 3 over 5, which is the 21 over 35. Oh, back on again. That's the 21 over 35. I'm gonna have to get used to writing everything down. And then we've got our negative 0.1, and then we've got our negative 0.8. Now the negative 0.8 is a larger negative, which makes it smaller. So it's greatest to least now. Which sign makes the statement true? Of course, positives are bigger than 0. Greatest to least. Okay, so we've got 3 and a little more, 3 and a little more. This one is definitely going to go last because it's least. Let me just push it last at the end. And I also have to know that that one has to be next. Now, between these two, I'm basically comparing 2 over 20 and 5 over 25. It just so happens that 5, write it down, 5 over 25 is 1/5, which is 0.2, and 2 over 20 is 0.1. It's 1/10. So it just so happens we want greatest to least, so we want these two reversed, and we're done. Which sign makes the statement true? Well, 39 over 80. Interesting idea here. 39 over 80 versus 1/2. Basically, that's the comparison. We want to see which is bigger. Well, it just so happens that this is 40 over 80, isn't it? So we want it this way. We want greatest to least. So again, turn this off for a second. We're going to put the biggest one first. It just so happens that we've got an 8 and 14 over 40 and an 8.96. This is less than a half. This one is less than a half. This is a lot bigger. The 0.96 is almost 9. Now, this one is less than a half, and this one is less than a half. So we know that they're in there. That is definitely last because the -8, this is in the middle. These two are the two we have to compare. And basically we're comparing 14 over 40, or 7 over 20, which is 0.35. All I did is multiply by 5 in case you're wondering what I'm doing. And we're comparing that with 6 over 25, which happens to be 0.24. So it looks like they're in order from greatest to least. Least to greatest. Now this time we want the smallest negative first. I'm going to start with the obvious stuff first. So this one is almost -2. This one is -1 1/4. Now the 1, since these are both proper fractions, the 1 has to be the largest. And 8 over 32 is 1/4, which is a lot less than 17 over 20. So there you have it. Now we want these numbers from least to greatest. So I'm going to start with the negative. So it's the least. Then I have a proper fraction. And then I have a 1.2. Now the big thing is what decimal goes with 18 over 20? Well, it just so happens that 1 and 18 over 20, do you know where I'm getting the 0.9 from? A couple of different ways to think about it. 20ths are 5 cents each, which makes this 90 cents. So it's 1.9. You could also think of this as 1 and 9/10. And that's how you read this decimal. So it looks like they're in order from least to greatest. All right, well, that took a while, didn't it? Which sign makes the statement true? Now this time we've got some pretty wild decimal here. Now some people are just going to grab their calculator and take 47 divided by 75. Be careful, make sure you divide it correctly. Let's see if we can't simplify it any. Since 47 is a prime number, this can't be reduced. I don't see any really nice way of changing this up because they're pretty close to one another. I think I'm going to go ahead and do the division. 75 into 47 and decimal, and 75 times 6 is 45 or 50. So it looks like it's 6. And 2, 0, 0, 0. And can I put it in more than 2 times? I can. In fact, I can put into 200. No, only 2 times. Dang. That's 150. Bring down the 50. Subtract. And now we will have a 6 repeating. 75 into 500. Well, we know it goes 6 times. 450, and it's 6 repeating. They happen to be equal. Go figure. And that's the time when the calculator comes in handy, doesn't it? All right, put these numbers in order from least to greatest. All right, so again, the negative 13 over 40 isn't very nice. I'm going to go ahead and change the negative 10 over 16. And if I multiply this, oh, you know what? I'm going to reduce it. I'm going to reduce it to negative 5 over 8. And I know that that happens to be negative 625. And negative 13 over 40, nothing nice there. Let's multiply it by 5. I'll show you why in a second. 13 over 40. I'm going to multiply this by 5, and I get negative 65 over 200. Well, that happens to be negative 0.325. So it definitely looks like they are in the wrong order. I need to turn them around. So it looks like we've got negative 0.625 first, then my negative 0.325, and then my 16 and 25 40ths. This one, a lot of people are confused about, maybe confused what I did here. You see this negative 65 over 200, I just divided this by 2. And that put it over 100. So I basically got negative 32.5 over 100, which is negative 0.325. There we have it. All right, which sign makes this statement true? This negative is a much larger negative than this one, and that makes it smaller. So we want it this way. Greatest to least. So we want the largest pot. We want the positive first. So the positive goes first. And the big negative goes last. All right, now we've got 25 into 184. It goes 7 times. 25 into 184 goes 7 times, and that's 175 with a 9 left over. So it looks like they are equal. Negatives are always smaller than 0. So there you have it. Boy, some of them were harder and some of them were easier. All right, least to greatest. Again, we want to put our negative first. So I'm going to turn this off. Let's put our negative first and our big positive last. There we go. And we've got greatest to least. My negative goes last. My 8.875 is first, and then my 8, and then my decimal. It looks like they're getting nice here, nice and easy. Okay, oh, only 3 more to go, yay! Now is 3/5. Oh, all right. 3/5 is equal to 0.6. So this is equal to 38.6, which happens to be bigger than 0.383. So we want that one. Put these numbers from least to greatest. All right, so we want to, let me turn this off. We want to put our big negative first, and then our small negative, and then our big positive. Maybe one more. Let's see. We want least to greatest, so we're going to start with our big negative. We want these guys at the end. Now, be careful. You see that 24 over 25 and that 24 over 32? When the denominator is bigger, the fraction is actually larger. So in this case, when the denominator is bigger, the fraction is actually smaller. So in this case, we've got 24 over 25, which is almost 1, and then we've got 24 over 32, which is quite a bit less than 1. Now I still got a 0.36, and I've got a 21 over 28. 21 over 28, if we divide by 7, you're going to get 3 over 4, which is 0.75. So these two are out of order. Back in order. Now we want least to greatest, negative, small decimal, a little bigger decimal, and then the 266s. Now the 24 over 32, let me show you another way to do this. 24 over 32, I want to be careful when you get near the end, because we do want to get our 100. 24 over 32 divided by 8 is 3 over 4. So this is 0.75. And 24 out of 25 is almost 25 out of 25. It's just missing 1. So this is 0.96. Take a look later and see what I did. I actually didn't multiply by 4. But I could have. I got 0.96. I kind of reversed this and took 4 cents away from the 24 out of 20. Sorry, 25 out of 25 is equal to 100 100ths. So what I did is I took 1/25, which is 0.04, that's 4 cents, and I took it away from the 100 and got the 0.96. So there it is. Do I have any more? Oh, I have another one coming. All right, zeros are bigger than negatives. All right, and my negatives are being compared with the same denominator. Now remember, bigger negatives are actually smaller. So this negative over here is actually bigger than that one. Okay, now we have the reverse. 62 is obviously bigger than 1. Common denominators. And it looks like we've got 1/3 or 1/27. 1/3 is much bigger than 1/27. 1 over 27 compared with 1/3. Lots of ways of doing this. One way is, remember that if you multiply these, you get 81. So if you cross multiply up, I'm looking at 3 and 27. This is 3 over 81, and this one is 27 over 81. Cross multiplying up is like doing this. And multiply that one by 27. We can see that that's bigger, and so 1/3 is bigger than 1 over 27. So I've got a couple more. Least to greatest, we need to put our negative first. And then we want our big positive last. And one more to go, it looks like. Now, this one is actually, sorry, that one is actually a bigger negative, which makes it smaller. So it's that one. And there you go. It took a little while, but there it is. I don't think I need to keep practicing. Hopefully, that'll help you out. Sorry it took so long. I wanted to go through each of those. If you have a calculator handy, it's going to help you out as far as some of them. But what you don't want to do is don't just grab your calculator every time you see a decimal or a fraction, only when needed. Try and use your shortcuts, and good luck on the rest. Bye.